I have driven past one of these without knowing what it was. It looks like a giant white bowling pin standing alone behind a fence in a flat field near an airport. No runway lights, no control tower, sometimes no sign at all. Just a white cone on top of a low equipment building, a ring of small white antennas around its roof, and a locked gate. It talks to aeroplanes. Not by sending them a picture, not by telling them where they are the way a phone does. It sends a radio reference that lets a cockpit measure a direction from the ground. And it is on a list. There is a Federal Aviation Administration spreadsheet that decides which of these stations stay and which ones stop. 594 of them are marked for retention. 302 are marked for discontinuance. 200 of those 302 are already off the air. The strange part is the timing. This object is being switched off at the exact moment the thing it backs up is getting easier to attack. GPS can be jammed. It can be spoofed. A cockpit display can show a position that looks completely plausible and is wrong. So the United States is keeping a smaller network of these old radio beacons alive as a safety flaw. The flaw has a name. It is called the VOR Minimum Operational Network, or MON, and the flaw is being measured down while it is being built. VOR stands for Very High Frequency Omnidirectional Range. The name sounds like a laboratory label, which is appropriate. It is a ground station that lets an aircraft work out its bearing from the station without seeing anything, without talking to anyone, and without a satellite. Here is how it does that, because the method is the whole point. The station transmits two signals at once on the same frequency. The first one is the reference. It is the same everywhere around the station, in every direction, at every moment. Think of it as a lighthouse that flashes at a fixed rhythm and flashes at everybody simultaneously. The second signal is the variable. Its phase shifts depending on which direction you are standing in relative to the station. North of the station, the variable is in step with the reference. East of it, the variable lags by 90 degrees. South, 180. West, 270. So the aircraft receiver does one piece of arithmetic. It measures how far out of step the variable signal is from the reference signal, and that number, in degrees, is the direction from the station to the aircraft. 0 degrees of phase difference means you are north of it. 90 degrees of difference means you are east of it. The receiver is not being told where it is measuring an angle out of two overlapping radio waves and reading the answer off a dial. That angle is called a radial. It is a line drawn outward from the station on a specific compass bearing. An aircraft on the 090 radial is somewhere east of the station, on that line, at an unspecified distance. On an older panel, the instrument that shows this is a course deviation indicator, or CDI. The pilot turns a knob to select a course. The needle then shows one thing only, whether the aircraft is left or right of that selected line, and whether the line leads toward the station or away from it. That is a much thinner piece of information than a moving map. It is also much harder to fake from a distance, and I will come back to why. The station identifies itself out loud. Every VOR broadcasts its own name in Morse code on its own frequency, on a loop. The station near the reference photos in this video is the Oceanside VOR TAC in Southern California. It sits on 115.3 MHz, its identifier is OCN, and what a pilot actually hears in the headset is dash 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 dot dash dot dash dot. That is OCN, repeating. If those letters are not there, the station is not to be trusted, and a pilot is trained not to use it. One correction to the picture, because the object and the name do not match. The white cone that people photograph is usually not the VOR antenna at all. The VOR is the ring of small elements around the roofline of the building underneath it. The cone is a TACAN antenna, the military system that was bolted onto the civil one. In August 1956, an interagency committee approved combining the civil VOR system and the military TACAN system into a single station, called a VOR TAC, as the key element of one common navigation system for both. That decision is why the object looks the way it does, and it dates the hardware. This is 1960s-era ground equipment, an analog radio site sitting in a mode field, still on the air. In the FAA's own inventory count from 2018, of 862 stations, 483 were VOR TACs, 354 were VOR with distance equipment, and only 25 were plain VORs. So the cone is the normal case. The bowling pin in the field is the standard American installation. GPS is better than VOR at almost everything. It describes a whole route. It calculates a position. It feeds systems across the aircraft. VOR gives you one line and a direction along it. The difference is not subtle. The question is what happens to that better system when somebody attacks it. The FAA's current guidance separates two attacks. Jamming is interference that stops a receiver from acquiring or tracking the real satellite signal. Spoofing transmits false satellite-like signals that a receiver may accept as genuine. Jamming makes the screen go quiet. Spoofing makes the screen lie confidently. The scale of the second one changed fast. In September 2024, an operational safety group called OPS Group published the final report of its GPS spoofing working group. Their finding was that roughly 1,500 flights per day were being spoofed, against about 300 per day in the first half of that same year. I want to say the caveat out loud before that number does any work in your head. That is a global figure, and it is overwhelmingly concentrated in specific regions. The FAA's own interference guide lists the major spoofing areas as the Eastern Mediterranean, the Black Sea, Russia and the Baltic region, the India and Pakistan border, Iraq and Iran, the Korean Peninsula, and airspace around Beijing. Almost none of that is over the continental United States. If you are flying from Denver to Chicago, this is not happening to you. But it has happened here, and that is the part worth walking through. On the afternoon of 17 October 2022, the FAA issued an advisory that GPS anomalies were dramatically affecting satellite-based arrival and departure routes for all airports in the Dallas-Fort Worth approach control airspace. The interference covered roughly a 40-mile swath. One runway at Dallas-Fort Worth was taken out of use because the approach that served it depended on GPS. Aircraft were rerouted. Researchers at Stanford later timed the event at about 24 hours, from mid-afternoon on the 17th to mid-afternoon on the 18th. The source was never identified. Nobody was arrested. It simply stopped. The advisory to pilots said, in effect, that if the satellite signal was not working, they should expect to revert to older ground navigation-based arrivals and radar vectors. And that sentence is the whole video in one line. The backup was not a theory that day. It was the arrivals. Watch what the reversion actually is, because it is not dramatic and it is not fast. The FAA's interference guide walks a crew through it as a checklist. Monitor the aircraft's estimated position uncertainty for any increase. Cross-check the clock because a spoofed signal carries a spoofed time. Deselect GPS from the navigation system. Inhibit satellite updating of the inertial system so the good sensor does not get poisoned by the bad one. Inhibit the terrain warning system's enhanced mode because a false position over flat ground can generate a terrain alert that is not real. And then the last line. Navigate using ground-based navigation aids. In cockpit slang, that is called going to green needles, because on many displays, the ground-based source draws in green, while the satellite source draws in magenta. That is what the white cone is for. It is not a better system, it is a different one, with a different failure mode. A jammer aimed at satellite reception does not erase a transmitter bolted to a concrete pad.
A spoofed satellite position does not move a station that has been sitting in the same field since the 1960s. The angle that instrument measures is generated locally from two waves in the air, and the aircraft can hear the station say its own name in Morse before it believes any of it.
So the FAA is reducing the network. Here is the arithmetic, cleanly, because two different sets of numbers circulate, and they are not in conflict once you see the frames they came from. The 2016 final policy set the plan. It listed a candidate discontinuance list in two phases: 74 stations in Phase 1 from 2016 through 2020, and 234 in Phase 2 from 2021 onward. That is 308, and 308 is where the widely quoted headline comes from. The denominator that usually travels with it, about 957, is not the FAA's frame. The FAA counted only its own stations inside the continental United States, and the FAA's own program slide gives that starting inventory as 896. Against 896, the July 2025 numbers are these: 594 stations planned for retention, 302 targeted for discontinuance, 200 of those already discontinued, and 102 still to go. 594 plus 302 is 896. The books balance. Roughly 2/3 of the network stays. The next three already have a date: Charlotte, Foothills, Holston Mountain. The Federal Register says December of this year. Now the promise that the remaining third is measured against. And this is the part that gets repeated wrong. The FAA does not promise a beacon within 100 miles. The Aeronautical Information Manual promises something narrower and more specific. Wherever an aircraft is in the continental United States, an airport with a conventional landing approach that does not need satellites will be within 100 nautical miles. Those are called MON airports. The stations that support their approaches are the ones being kept. The coverage promise has its own boundary. The manual says the network will provide nearly continuous VOR signal coverage at 5,000 feet above ground level across the airspace system outside the western United States mountainous area. Inside that mountainous area, the FAA says there is no plan to change the navigation aid and route structure at all. Below 5,000 feet, coverage exists, but the FAA says it may not be continuous. The manual also gives the network its actual job title. It calls the MON a reversionary service, provided for aircraft that are unable to continue satellite-based navigation during a GPS disruption. Reversionary, something you fall back to. The MON is a design safety flaw, not negligence. I want that said plainly. The FAA is keeping about 2/3 of the network. It published the criteria, it published the list, and every single removal goes through its own study and its own public notice. Nobody is sneaking anything off the air. But the shape of the plan is still the story. A flaw is a number somebody chose: 5,000 feet, 100 nautical miles, one conventional approach. And a station only survives if it holds up one of those numbers, not because it works, not because it is paid for, because it is load-bearing for a promise. 200 are already off. 102 more are scheduled. Each one goes quiet on a specific date, in a specific field, and the fence stays up for a while afterward with nothing behind it. The cone in that field does not know any of this. It transmits its two waves and says OCN in Morse code, over and over, to aircraft that mostly are not listening, so that on the day the satellites lie, something in the air can still measure an angle from the ground. That is what is being switched off, not the old way of flying, the fallback.